any of the buck or boost converters or buck boost converter or different topologies that we've seen, like flyback converter and so on. Okay, the next thing I want to talk about is different, let's say like we have a grid tie inverter, and how, like what are the topologies that we can have for connecting the solar panels to the inverter, right? So in this case, we would have our solar panel and we want to connect to grid, right? So to do that, we need an inverter that converts, it's basically a converter that converts DC voltage to AC voltage. Now, there are mainly 4 methods. This part I'm getting it from a course from the University of Delft, Technical University of Delft, but in Netherlands. But this one is not in your course notes in this way, but it's I feel it's good for you to know. So there are multiple methods of implementing this. The first one is called central. The second one is called module, string, and multi-string. So these are the methods that we want to implement maximum power point tracking and connecting your inverter to the solar modules or solar panels. So in the central one, what you have, you basically have your solar cell, solar modules or solar panels connected, and you just like have one big inverter in charge of inverting the voltage. So you would only have one inverter for the whole thing, okay? So it means that you would have low investment costs. You don't have, inverters are not cheap, like they're expensive, right? So you would have only one, and the problem here is that like you would have long DC wires though, right? Because this gets extended, and DC cables are not that cheap either, right? So this is like the central configuration. It's usually used in very high power application, like let's say kilowatt to megawatt. Okay, so this is the central, and the Mppt algorithm is implemented in this inverter. So like it try to adjust the voltage based on the so you might have also like a DC-DC converter here. So you adjust the voltage here in this power electronic interface to get to the maximum power point. The second method, module configuration or module connection or module inverter, sorry. You would have like something called micro inverters. So in this case, for each solar panel, you would have an inverter, right? And it's a micro inverter, and it gets connected to another inverter that would just like run another it's just like, let's just like do it for a micro inverter. So like for each solar panel we have micro inverters. So you need like more inverters, but in this case you would have low DC cables. It's more flexible. So like in the previous case, you would have like one algorithm for all your solar panels. So what if you have partial shading in one of the panels or one of the modules, right? But this one is more flexible, but you would need more inverters, so the investment cost is going to be too much. If you put many of these together, you would get, so sorry, like if you if you put many of these together and then you would have a string here and like have connection here, you would get to the string connection and multi-string. Multi-string is like many of the strings put together. A string is many of the modules put together, right? So if you have many of these, combine them, you get to a string, and if you combine these together, you get to a multi-string. So we might end up with something like this, an inverter that I'm just gonna show panels like this, and here's the AC, so have another inverter here. This is the string. My cat just sneezed. Bless you. And in the multi-string, what we have is basically one inverter that goes to different DC-DC converters, and this supply, not sure if you can see this corner. No, you can't, sorry. So we would have a central inverter that's connected to AC, and then we would have DC-DC converters that would supply a string of solar panels, and you would hear like you would have another DC-DC converter that would supply another string. So this is called multi-string. Okay, usually the range of power that we implement these are like this. This, as I mentioned, this one is between 50 in the kilowatt or megawatt range. This one is between 50 to 50 watt, 500 watt, and the next one is between 500 watt into the kilowatt range, 1 kilowatt for example, and this is going to be like in the kilowatt range. Okay, so that's what I wanted to mention about like different configurations that we have. Now let's take a look at your course notes and see what else we have there that I was not able to cover here. So I want to see what Dr. Jeff has prepared for us. So we covered perturbance observation, we covered partial shading. So like if one of the solar cells is shaded, or if it goes out of order, that's why we have bypass diode. So we want to bypass that, because as like one diode, if it goes out of order, it would have high resistance, right? So like it would act like a sink. We want to bypass it, right? So this is like what a bypass is. So it wouldn't be a source anymore, it would be sink, right? So we would have the same thing for our panels.